When you are asked to differentiate with first principles, you must use the first principles. Okay, so if you're asked with first principles, this is the limit of h to 0 of fx plus h minus fx divided by h. This is something that you have to learn off, so absolutely no excuses for not getting it. Let's start with our fx plus h. Okay, I've got a third x plus h squared minus x plus h plus 3. So if I'm adding x plus h, I'm literally doing that everywhere that I originally had x. That's going to be a third x squared plus 2xh plus h squared minus x minus h plus 3. Okay, which is x squared over 3 plus 2xh over 3 plus x squared over 3 minus x minus h plus 3. Okay, then let's look at fx plus h minus fx. And I'm subtracting the whole lot of the fx term. So I'm subtracting a third x squared minus x plus 3. That minus sign affects all of these things because I'm subtracting the entire term. So x squared over 3 is 2xh over 3. So that's my third, by the way, having an effect on all of these. Okay, so what I should have is that my entire fx term always cancels. And I'm left with 2xh over 3 plus h squared over 3 minus h. Okay, and at this point, I'm bringing in my over h. Remember that this is ultimately what I want to achieve. Okay, so the first thing I'm going to do is factorize out the h on the top line because it's a common term, and this should always happen. Okay, h into h goes once. That means that I can cancel the h's, and my last step is to limit h to 0 of 2x over 3 plus 0 over 3 minus 1, remembering that that was h, okay, which gives me my derivative of 2x over 3 minus 1. Now I completely understand that you can look at this and you could say straight away that that is going to be 2x minus 1, but I have to do it by first principles when asked. The derivative for each of these should be relatively simple. For the first one, this is not a product rule. There's no product here. This is a subtraction sign. So I'm literally just differentiating each part. So fx is going to be equal to 4x. The 2 comes down. The x drops in power by 1. Minus. This term here needs to be rewritten as 3x to the power of minus 2. It's not a quotient rule because I don't have variables on the top and the bottom. Okay, it's only a quotient rule if I have variables on the top and variables on the bottom. I can write this as 3x to the power of minus 2, which means that I don't need to use the quotient rule. My minus 2 comes in front, so that'll be minus 2 by 3 is 6x, and my power drops by 1, so minus 2 drops to minus 3. That leaves me with 4x plus 6x to the minus 3, which is 4x plus 6 over x cubed. Okay. The second one, y is equal to 4 sine 6x. Again, not a product rule because this is not a variable. 4 is a constant, so it doesn't need the product rule. dy dx is equal to 4 sine becomes cos. I keep the 6x and I multiply by the derivative of 6x, which is 6. Okay, so okay, which leaves me with 6 by 4, which is 24 cos 6x. The last one, you have y is equal to 3 e to the x squared. Remember, e to the x does not differentiate. Okay, have a look at those memes on Edmodo, okay, which show you, okay, highlight the fact that e does not differentiate. So dy dx, 3 is a constant, so it remains there. 3e to the x squared. Okay, you don't differentiate the x squared on the e, it stays exactly the same. I then multiply it by the derivative of the x squared, which is 2x. Okay, the original stays exactly the same. Okay, e when it differentiates stays exactly as it is, but I multiply it by the derivative of the indice. Okay, which leaves me with 2 by 3 is 6x e to the x squared. Okay, 2x by 3 I can multiply. These terms are all being multiplied, and e to the power of x squared stays exactly the same. Okay, again, this is not the product rule. Okay, this is a subtraction sign. Okay, if it was x plus 6, in that case, that would be a product rule. Okay, but the minus sign here makes it not a product rule. So x differentiates to 1, remembering that this was x plus 6 to the power of a half, minus the half comes in front. The chain rule says I keep the base exactly as it is, drop the power by 1, and I multiply by the derivative of the base, okay, which in this case actually just becomes 1. 1 minus a half times 1 over the square root of x plus 6. 1 minus 1 over 2 root x plus 6. And that's as far as you needed to go with that one. The equation of the curve is x sine 2x. This is a quotient, is a product rule. Okay, so uv. So dy dx in this case is going to be u dv dx plus v du dx. Okay, du dx is the derivative of the x term, which is 1. dv dx is the derivative of sine 2x. So sine becomes cos 2x multiplied by 2. Remember, you keep the same base. So cos 2x, sine becomes cos, keeps the same base, and I'm multiplying by the derivative of the base. So the derivative of 2x is 2. Then I apply my rule. So u is x by dv dx is 2 cos 2x plus v, which is sine 2x, by du, which is 1. Okay, so this is 2x cos 2x plus sine 2x. And I'm told at x is equal to pi over 3. Okay, remembering the pi is 180 anytime I'm talking about sine, cos and tan. So 180 divided by 3 is 60. You can use 60 if you want. Okay, 2 times 60 cos times 2 times 60 will be 120 plus sine of 120. And you will get, so you can throw all of that into the calculator, you will get 120 plus root 3 over 2. And it's fine to leave it at that. Okay, find the coordinates of the 2 points on the curve where the slope of the tangent to the curve is 3. So this time you know what the slope is. You don't have something to sub in for x. I'm also asked for coordinates, so it wants x and y. Differentiating this, it is not a product rule. That's a plus sign. Okay, a product is only when two things are being multiplied. Again, if it was x squared ln x, that would be a product rule. The plus sign separates them and I can just differentiate them part by part. So that becomes 2x plus 1 over x. That's it for the differentiation. I'm told the slope of the tangent to the curve is 3. Remember the derivative. So this derivative accounts for all possible slopes of the tangent. Okay, I know that the slope to this tangent is at 3. Okay, so I know that the slope is equal to 3. I need to find the x point. So where is the slope equal to 3? Multiply everything by x. And I end up with a quadratic equation. Okay, solve my quadratic equation and you'll end up getting x is equal to 1/2 and x is equal to 1. I'm only halfway there because I've got to find my y coordinates. The only place you can find y is from the original equation. So y is equal to 1 squared plus ln 1. Okay, and that gets me 1. So I have the point 1, 1. And y is 0.5 or 1/2 squared plus ln 0.5. You'll have to put that onto the calculator and it's minus 0.44. So 1/2 and minus 0.44. Okay, question 3. If y is equal to e to the power of nx, find dy dx. Okay, n is a constant here. Okay, so e to the power of nx does not change. Remember, e differentiates to the exact same term. And then I multiply by the derivative of nx. So nx would be literally like you were differentiating 3x would become 3, 25x would become 25. Okay, nx becomes n. So differentiating it by n. Okay, so e to the x is, sorry, the dy dx is n e to the power of nx. Then my second derivative, d2y dx2, is the derivative of this. Okay, it's not a product rule because n is a constant. It's just a number. Okay, I can only have one variable when I'm differentiating and my variable is x. So I have n e to the power of nx, remembering that e does not change. So e to the power of nx just differentiates to e to the power of nx. You then have to multiply by the derivative of the indice, okay, which is the exact same as the last time. Okay, n in front is just a constant, that stays there. Okay, I'm differentiating x or nx, which just becomes n. Okay, so that's n squared e to the nx. Then to use this, d2y dx2 is n squared e to the nx minus 5 times dy dx, which is n e to the power of nx, plus 6y, so plus 6 times e to the power of nx. Okay, y is here, equals 0. E to the power of nx is in all of them, so I can divide it out completely. N squared minus 5n plus 6 equals 0 is your quadratic equation. When you solve it, you will get n is equal to 3 and n is equal to 2, okay, which are the two values of n to solve this.